Resonance occurs when there are multiple ways of writing the dot diagram for the same substance, all of which are valid Lewis structures. However, reality is somewhere in between these dot diagrams. Each diagram is considered a resonance form, but reality is a hybrid of these different forms. For example, NO2 minus has two different resonance forms. Now, they look like exactly the same thing. They're mirror images of each other, one single bond and one double bond coming off of the nitrogen to each oxygen atom. However, if one of these were the actual structure, then we would have one single bond and one double bond coming off of the nitrogen. So the bonds between the nitrogen and the oxygens would be different. Double bonds are shorter in length and stronger than single bonds. However, when we look at the actual NO2 minus ion, that's not what it looks like, either one of those. Both NO bonds are the same length and the same strength. So while we can write it in either one of those two ways, which is why we have the double-sided arrow saying that those are resonance forms of the NO2 minus ion, reality is a hybrid of those two. So the electronic structure of the whatever substance you're trying to draw the diagram for, molecule or ion in this case, is always the average of that's shown by the resonance forms. It's not that the molecule is alternating between the two different resonance forms, it's a mixture of the two at once. So instead of having one single and one double bond coming off of the nitrogen, what we have is a 1.5 bond between the nitrogen and each oxygen. So it really is a mixture of those two resonance forms. So one way that's been used to explain it is a rhinoceros is kind of like a mixture between a dragon and a unicorn. A rhinoceros is not a dragon one moment and a unicorn the next, but it has features that are similar to both. So the actual molecule looks like the rhinoceros, but we can use the diagrams that show the dragon and the unicorn to kind of represent a little bit of what's going on, but neither of them fully explains what's going on with the molecule at any given time.